Hello, geometry. Hope you didn't go to the isosceles and equilateral triangles. I don't know if you recall isosceles. Two sides are congruent, equilateral, three sides are congruent. So you've had this in the past, but now we're going to play around with it. So my learning targets, I can solve theorems about, I can use theorems about isosceles and equilateral triangles, and I can solve real life problems using congruent triangles of those type. Okay, so first of all, what we're going to do is classify each triangle by its sides. Well, if I have a triangle that's 2 by 2 by 2, it looks like this, and all three sides are the same, that's equilateral. Okay, notice it's by the sides. Hopefully I'm spelling that right. How about this one? Two sides are 7 feet long and one side is 11 feet long. So it'll look like this. So two sides are 7 and then this is 11. That would be isosceles. I-S-O-S-C-E-L-E-S. I do know how to spell that one. How about this one? 8, 9, 10. I don't know. Anyway, they're all different, so this will be scaling. Now, how about D? In triangle ABC, if measure of angle A is 70 and B is 50, what is measure of angle C? Well, remember, all three angles add up to equal 180. So if I take 180 minus 70 plus 50, then, let's see here. 70 plus 50 is 120. Take 120 away from 180, you get 60. And that is what the measure of angle C will equal. All right, can you see it over there? Okay, in triangle DEF, D and E have the same measure, and F is 26. So we're talking an isosceles triangle here. And this is going to relate to some of the information we'll learn later on. Well, I'm going to take 180 minus 26, and you get 154. Now these two are going to be congruent because it says they're the same measure. So I'm going to divide that by 2, and you get 77. All right, so far so good. 77. I am still getting a little glare, so much for dropping $50 on that lamp. Okay, isosceles triangle. Here we go. A triangle is isosceles. All right, so let's circle that. Well, just decorate it. If it has at least two congruent sides. So you could say an equilateral triangle is isosceles because that's true. It just happens to have three congruent sides. When an isosceles triangle has exactly two congruent sides, then the two sides are called the legs. Okay? The angle formed by the legs is the vertex. The third side is the base. The two angles adjacent to the base are called base angles. Okay, so here's a really nice picture. Sorry that yours is printed off in black and white. But what thing I want you to remember is the base angles are congruent. Okay, so that's the most important part. It's weird on how this red pen turns out orange. All right, so let's look at some theorems. Base angles theorem. All right. If two sides of a triangle are congruent, then the angles opposite of them are congruent. Basically, this side opposite to that angle, side opposite to that angle. So you start with the sides, you end with the angles. So this is my if part. This is my then part. Those are angles. So, and that's a B. Congruent to C. All right, now, the converse. You start with the angles, then you get the sides. Start with the angles, then you get the sides. Okay? That's a bad B. This is printed out really bad. Okay, moving on. Ooh, already getting to a proof. Now, there's only one little bit about this proof that I kind of have an issue with, but that's okay. It's a proof that they want you to cover. So, okay, first of all, proof of base angles. So we want to prove that the base angles are congruent. So we have an isosceles triangle. If you have an isosceles, we already know that these two segments are congruent. So that's our given. Then it says M is the midpoint. So find M. Like this line didn't exist. We would add it in. Find M. So it's a midpoint of BC. It's just definition of a midpoint. Okay. Draw AM so it bisects. So then you would draw that in. So shame on me, I should have put a picture in here without that line drawn in. 2 points make a line. Yeah, that comes up every once in a while. You can draw midpoints. So because I just drew a midpoint, I now know that BM is congruent to CM. Okay, that's what a midpoint does. And then I know AM is congruent to AM. It's the line in the middle. That's reflexive. So the triangle on the left is congruent to the triangle on the right by side, side, side. And if you recall, if the triangles are congruent, all of the corresponding parts are congruent. So my base angles are not congruent also. By C, P, C, T, C. Such a helpful theorem right there. Corresponding parts are congruent, triangles are congruent. All right, example 2. If measure of angle B is 40, obviously this is isosceles, what are the measures of A and C? Well, I'm going to just take 180 minus 40. I get 140. Well, these two angles have to add up to equal 140, and they're the same because I know if I have an isosceles triangle, the base angles are congruent. So divide by 2, you get 70 degrees each. Next. Ooh, corollaries. You ready for this? Now we're going to throw in the equilateral triangle stuff. Corollary to the base angle theorem. If a triangle is equilateral, okay, so if all sides are the same, then we know all the opposite angles are the same. Okay, so if it's equilateral, if our sides are congruent, then our angles are congruent. And then the corollary to the base angles theorem, if the triangle is equal angular, so if you start with the angles, then we go with the sides. Okay, so it's the flip-flop. Find the measure of all three angles. Okay, well, I know, okay, first of all, I have an x here and a y here, so that's kind of an issue. I'm going to have a 52. We can add them all up and equal 180, but that's not going to help me because I have two unknowns. However, take a look at this. This segment's congruent to this one. That means I know this is congruent to this. So y is equal to 52 degrees. All right, so far so good. Well, from there, I'm going to add 52 plus 52, and I'm going to take it away from 180. And I'll get 76. So that means this right here has to equal 76. So I'm going to subtract 6 on both sides. And then divide by 14. X is 5. So I'm not really quite done yet because it says find the measure of all three angles. So remember, most students will stop right here. You've got to plug it in. So I know this is 52 and I know this one's 52. So I have to substitute 5 in for X here. So I have 14 times 5 plus 6. That's going to equal 76. So please double check my work, okay? Last two examples. Okay, here we go. Solve for X in both diagrams. Well, if you look, this is an equilateral. That means all three segments are the same. So I can set these two equal to each other, or these two, or these two. It doesn't matter. I'm just going to pick these two. So 4x plus 8 is equal to 6x, because they're congruent. Or you can choose this one. It's up to you. I'm going to subtract 4x on both sides. And I have 8 is equal to 2x. X is equal to 4. So substitute it back in. Here, 6 times 4 is 24. Then this has to be 24. Then this has to be 24. And double check. 3 times 4 is 12 plus 12. 4 times 4 is 16 plus 8. So they're all 24 units of some sort. All right, how about this one? Whew, look at this. Okay, so this is an equilateral triangle. That means this angle is going to be the same as this angle. Okay? Well, here's an exterior angle. This makes a straight line. So if this is 124, this angle is going to be 56. Okay? So if this angle is 56, this one's 56. I know this is confusing. Just pretend that this triangle part's not there. Okay? So see this little right triangle symbol? If this is 56, this is 34. Now, look at the right side. This is also going to be an isosceles. So if this is 34, this is also 34. So the answer is B for Bob. All right, here's our homework assignment and our Common Core standard. Everyone have a nice evening and keep warm, Badger fans.